In how many ways can the letters of the word exam be arranged? All right, and here's the key with all of this. It's a very special note. You know, I wrote this in a little, but I'm going to star this, underline this, whatever, because there's going to be two cases. I'm going to ask you one time on how to rearrange the letters in a word. It very much matters if every word, like in the word exam, everything's different. But what if I gave you the word Mississippi, where some letters repeat? It matters if you have repetitions in there. So if it's not repetitions, you don't have anything to worry about. But just go up there. Well, the word exam has 4 letters. So how many ways can they be arranged? It's just simply 4 factorial. But so you can think about it like this. I'm going to write it out. It's 4 times 3 times 2 times 1, 4 factorial. And you don't have to plug that in your calculator. You answer the question when you write 4 factorial. I get what you're saying. You're done, you know, so don't even worry about if you don't want to plug it in your calculator. You can leave it in this form. But if we go back to the multiplication principle, let's think. I'm going to take the word exam, which has 4 letters in it. 1, 2, 3, 4. Think about those as the letter slots. And I want to rearrange them. So let's take all these letters, think of it as like alphabet letters that kids play with, and I'm going to throw them on the floor. When I go to reach up that first letter from the floor, how many options do I have? Well, I have 4 different letters I can choose from. I can get the E, the M, the A, the X. Okay, I've picked it up and I've put it in a spot. Now I'm going to go back to the floor. How many options do I have to choose for that second letter? Well, there's 3. And then I put that down. Then I go back to the floor. There's only 2 letters left to choose from, and now there's only 1 left to choose from. So that's another way to look at it, is 4 times 3 times 2 times 1, which is still the exact same thing. All right, now, that's when you're going to use specifically every single letter, every single person, everything's going to get used up. It's always going to be however many things that are there, like in the example, 4 letters, so 4 factorial. There were 10 people, 10 factorial. There's 5 books, 5 factorial. But what if you only want a small group of them? So instead of, say, of all 5 books, I just want to rearrange 3 of them. Or instead of picking all 10 students, I only want to use 8 of them. Okay? And that's what this next part is about. And here's a new notation for them. Again, they always have to be distinguishable. You should be able to tell apart each of the items from each other. And we want to rearrange just the small group of them in a specific order. And here's a brand new formula for you guys to know. And what this is saying, P stands for permutation. So the permutation, the number of orderings of out of 10, I'm going to select R of them, is n factorial divided by, first of all, n minus R. So subtract that first and then take the factorial of it. Okay, I want you guys to take 2 seconds. If you don't have your calculator out, will you pause the video and go grab your calculator, because I'm going to show you how to use this in your calculator. Okay, if you just pull out your calculator just real quick, and I want everybody just on your home screen, just turn it on, and then right away you just have to hit the math button. The math button is the one right above your matrix one. That X inverse just hits math. You don't have to do second math, just math. And what comes up is 4 different options along the top. It says math, then NUM, then CPX, and then PRB. You want to go right to where it's highlighting on PRB. That stands for probability, and that's what we're doing this chapter, is probability. Okay, and then as you look closely at what comes up when PRB is highlighted, so far I haven't hit enter or anything like that. All I did was hit math and scrolled right to where PRB is highlighted. And then look closely, and this is what, look at number 2. Number 2 says that NPR, that's the exact same thing as what's listed right here. Whether you have P with a parentheses NR or you write it as NPR just like that, it's the exact same thing. Number 3, that NCR, we're about to use here in the next couple examples coming down. And then obviously look at number 4, it looks familiar. That's that factorial button. So this is all coming under that probability. And you would just go down to kind of highlight what's going on. All right, so let's use our calculators and kind of do this one by hand or 2 just by using our calculators. Either way we want to. But it says how many 2-letter permutations can be made from A, B, C, and D. So we're going to, say, out of 4 letters, what we're doing is we're choosing 2. And I'm going to spell choosing correct today. So in other words, N equals 4 and R equals 2. So we want to know how many different permutations. So it'll be a permutation of of 4 items, I want to pick 2. Now I can do one of two things. If I do this by hand, then I want to use this main formula up here that I have written. So by hand, it'd be 4 factorial divided by 4 minus 2 factorial, or 4 factorial over 2 factorial. Well, that's 4 times 3 times 2 times 1 over 2 times 1. And if we kind of mark common stuff out, it comes out to 12. Okay, if I want to do by hand, then I use this formula up here. If I want to do it by a calculator, let me show you how to do it by a calculator. So why don't y'all come with me? We're going to go to, first of all, make sure you're in your home screen. Because in your home screen, it's very important. You have to list your number, you have to list your N first. So here's the calculator way. Our N is 4, so type in the number 4 when you're in your home screen. Okay, now from there, hit Math. Go right to where PRB is highlighted. Go down to where number 2 is highlighted, and then press Enter. Because then your calculator is going to type in the NPR, and then what you have to do is hit the number 2. So this is exactly what your home screen should look like, just like that, and then hit Enter, equals, and it comes out with 2, or with 12. So either way, whether you choose to go the longer way by hand and use the formula itself, where it's just 4 factorial divided by 2 factorial and just kind of cancel them off, or you choose to use your calculator, either way, it's going to get you the exact same answer. All right, so let's try this again. In how many ways can a club of 30 members select a president, a vice president, and a treasurer? Okay, our grand total people we can choose from, which is our N, is 30, and we're wanting to select 3 positions, a president, a vice president, and a treasurer. So we have 3 options we want to pick from it. So this is the one where we're going to do it by hand. Then it's going to be a permutation of those 30 people, I want to select 3. So it's 30 factorial divided by 30 minus 3 factorial, or 30 factorial over 27 factorial. And watch here, I want you guys to pay close attention on how I'm cleaning this up. It's 30 times 29 times 28. I'm right here, I'm going to write it as 27 factorial, because normally it'd be 30 times 29 times 28, 27, 26, 25, all the way down to 1, right? But look what happens right down here in the bottom. Wouldn't 27 factorial start at 27 and go all the way down to 1? So by doing this, that's going to cancel with all of those taking the rest of the way down to 1. So really, all you have to do is go 30 times 29 times 28 and get an answer of 24,360. Okay. Whereas, obviously, a little faster is if I use your calculator, then we're going to type in 30 in the home screen. So if you want to do that real quick, hit 30 and go Math, scroll over to Probability, and down to number 2, so it highlights the NPR, hit Enter, then type in the 3 and hit Enter. And we get the exact same thing, 24,360. So let's go back to, let's interpret our answer here. If you only have 30 members, you have 24,000 options on just how to pick any 3 of those members and say, hey, you're going to be president, you're going to be vice president, and you're going to be treasurer. It's kind of crazy. How many times were you in a room of 30 people and there was that many ways just to select 3 people? Pretty cool though. All right, the next part. This is the one, this example right here is where I was talking about, is where you want to, if you want to take like the words exam and you want to rearrange the words in exam, you have to pay close attention. Is anything in there repeating or not? So specifically, let me read this out to you. Assume you want to rearrange, or you want to arrange all N objects. So like the word exam, I'm going to rearrange the E, the X, the A, the M, everything in there. But some of the objects that make up N repeat. So not necessarily everything in there is distinguishable. So that's why we have the non-distinguishable. We have some repetition going on in here. And the total number of ways to arrange these objects. Okay, before, the total number of ways, the permutations, was just N factorial when they're all different. When they're not all different, look how it changes. It's still the N factorial on top, but what we've got to do down here is divide by the repetitions. So the easiest way to look at that is, let's go to this next example so you can see this real quick. Okay, how many ways can the letters of the word Tennessee be arranged? So there's the big point. It was repeating. We don't have the word exam anymore. We now have the word Tennessee. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, well, the number of permutations is 9 factorial. And if they were all different, we'd be done. But because we have repetitions, we have to divide off the repetitions. How many, let's go down the line. How many T's? Well, there's only one T, so that's not going to really do much. You can divide by 1 and not change anything. How many E's do we have? 1, 2, 3, 4. So I'm going to divide by 4 factorial. See how it says factorials on each of those? How many N's do we have? 2. So divide by, again, 2 factorial. And then how many S's do we have? 2 factorial. Okay, so when you're trying to rearrange something and there's objects in that are actually identical and you can't tell them apart, the way to figure out how many ways you can rearrange it is the grand total on top divided by each of the individual repetitions. And like I said, here you can just leave your answer like that if you want to. If you want to figure it out, you just type it in, make sure all this down here is in parentheses and that we have these multiplied together. The basic multiplication principle. Let me think about telling you guys just something different. Is what if you had 5 people, but 2 of them were twins? Okay, a pair of them were twins, and let's say they were so identical so you really couldn't tell them apart. Then how many ways could you rearrange those 5 people? Well, it would be 5 factorial, first of all, but 2 of them repeat, the 2 twins, so then it would be divided by 2 factorial. If all the students were completely different, it would be 5 factorial. But if you got a set of twins, then it would be 5 factorial divided by the 2 that look the exact same. Or let's say you had a set of triplets, then it would be divided by 3 factorial if they were all identical and you couldn't tell them apart. Okay?